Hello, this is Screencast 6, CICS address space CPU. Today we're going to talk about the same customer estate as in Screencast 5. There are 4 ZOS systems which we're calling A, B, C and D. Now this time we have 3 distinct CICS applications, B, M and P. I'm sure you can spot the naming convention right there. Each application has multiple regions on each ZOS system, and they are equal numbers in fact on each ZOS system, although the number of cloned regions varies from application to application. So using the same code as I mentioned in Screencast 5, I'm looking at CPU for the major address spaces in this group, in this case CICS address spaces by time of day. To go to the bottom of the slide, SRB time is minimal as you'd expect for CICS, and here for this particular customer both zip and zip-on general purpose engine CPU time is minimal as well. So let's look at the picture for one particular system, SysA. So in blue we have the B application address spaces, and in orange we have the M application address spaces, and in green we have the P application address spaces. I keep saying address spaces, I really mean specifically because this is CICS regions. Now you'll notice that they have different peaks, in fact different profiles, the 3 applications. So B, for example, peaks early in the working day and then slopes off a little bit and then dies away. Whereas M peaks slightly earlier and keeps going all the way through till late evening. And finally P peaks very early in the morning and then comes back again during the working day and again slopes off overnight. So 3 completely different profiles for the 3 different CICS applications on this one system. One thing you'll notice is, given that I've color coded each region in the application, they form quite tight bundles of graph lines. I'm sure that's not the proper technical term, but I'm going to use the term. So they're bundled quite closely together, which implies a certain amount of effectiveness in routing the work evenly to the various clones in each application. And by the way, it's at least 2 CICS regions for each application for each system. Now this is just one system. If we then go ahead and look at multiple systems, same day, same color coding, and what you see here is that the address spaces are again quite tightly bundled, and obviously because of that the profile is very similar to what it was on just the one system. So I just think this is an interesting way of looking at CICS regions, understanding whether the clones really are balanced, and maybe if you didn't know the naming convention you'd be able to spot clones this way. So I think it's quite an interesting set of data here.